Hey everyone, Mr. Skelton here, back at it. Lesson 10, Unit 6, and today we're going to be solving logarithmic equations. Back in Lesson 9, we solved exponential equations, and so today, again, I always want you to be thinking about this. I want you to be thinking about inverse operations, okay? And I want you to be thinking, what's the opposite of logarithms? Exponential form, right? And what's the opposite of exponential form? It's logs. And what I'm going to put right in the middle of those arrows is the word solve. And the reason I'm doing that is because when you're given a problem, if the problem is in log form, you're going to solve it by using exponential form. If the problem is in exponential form, then you're going to solve it using logs, okay? And so when we jump down to, I'll try to keep that in the picture as well, when we jump down to these first few problems here, you'll notice what is in the problem? Well, in the problem we have logarithms. So if in the problem we have logarithms, we're going to solve using exponential form. If you take a look at number 1, you'll notice there's no base in the log. What does that mean? That means it's a common log which has always a base of 10. And so as soon as you have that, or you know that, you want to change or convert this logarithmic equation into exponential form. What power on 10 equals 3x plus 1? So what power? We know that logarithms equal exponents, so what power on 10? It's 10 to the 5th equals 3x plus 1. And so we just take our calculator out and we're going to solve that now for x. So 10 to the 5th power is going to give me, let's see, 1, and then 1, 2, 3, 4, 5. So that's going to give me 100,000. 1, 2, 3, yep, 100,000 equals 3x plus 1. And then I'm going to subtract 1 from both sides. So minus 1. And then I'm going to divide by 3. And I should get x equaling 33,333. A lot of 3's there, okay? So go ahead and try number 2 on your own and see what you get. Hit pause and then check back with me. All right, same kind of situation on number 2. You have a log, so if in the problem is a logarithm, we're going to solve it using exponential form. So I'm going to have 10 to the negative first power equaling 7 minus 2x. Now, 10 to the negative first. You can do this you can solve this a couple different ways. It's totally up to you on how you go about doing this. But when I see 10 to the first, I know that that is 1 over 10, or 1/10. All right, so 1/10 equals 7 minus 2x. And this is a little messy here, but I'm going to minus 7. And we can go decimal here. It's not a big deal. All right, I don't need it in fraction form, so I can go negative 7. Basically plus 1/10, and that's going to give me negative 6.9, which makes sense. Didn't even need a calculator for that. And then I'm going to divide by negative 2 then on both sides, and when I do that, I get 3.45 as my answer. Okay. All right, let's flip it over, see what we got here. Pretty quick lesson here. We kind of broke up solving logs and solving exponential problems in 2 different lessons. We probably could have put them together, but hopefully it makes it a little bit easier for you. Okay, so you can see that these are slightly different. Honestly, you could go ahead and hit pause and try these and just see what you can do. Just try some problem solving here and see what you can come up with, and then check back with me. All right, so when you look at this, what are you thinking? I know when I look at this, I'm thinking, all right, it looks like a problem that we've done before where we need to condense or simplify or write as a single log. Whenever you're solving, right, and you have more than one log, we want to condense first. We need to get that into a single logarithm, okay? And so that's what I need to do here is I need to make this use some condensing properties, quotient, product, power property. 2 out in front, this is going to become a 2 there on that x, and then the minus sign means division. So basically what I have here when I condense this, and I'm kind of doing 2 steps in one, that'll be x squared divided by 3. So x squared divided by 3 equaling 2. Now notice again, there's no base on these logs. That's the common log 10. All right, and so then now I can convert this. Now it turns into a problem that we just kind of did before. So what power on 10 equals x squared over 3? That would be 2. So 10 to the second equals x squared over 3. And we can go, 10 squared, or 10 times 10 is 100, right? So we should be good there, no problem. And then we get 100 equals x squared over 3. We can times both sides by 3 to get rid of my 3's, and I have 300 equals x squared, and then I'm going to take the square root of 300, so second square root of 300, we get x equals 17.32, okay? Questions on that? If I said to leave it in simplest radical form, remember simplest radical form, could you break down 300? 100 times radical 3, which would be 10 radical 3, that'd be simplest radical form. No, we haven't done that in a while. Good review there for you real quick. I will be asking probably for decimal answers on a quiz or test, but just throw that at you there for review purposes. All right, number 4, excuse me. Again, I have two logs in the problem with an equal sign, so I'm solving. It's an equation. I got multiple logs, so I'm going to condense. I have a minus sign, which means division, so basically I have log base 10, because it's common log, of 6 divided by 3x. Equaling negative 2. Now, I can reduce this, right? What's 6 divided by 3? 6 divided by 3 is 2. So we can do that. If you didn't want to, you don't have to, but it's okay. It's just a normal fraction there. So basically log base 10, 6 divided by 3 is 2. Now, when students would simplify this, you got to be careful. The x is going to stay on the bottom. Notice the x is not on top. The quick mistake here on this is students just write down 2x. So be careful with that. Okay, now we're converting, so 10 to the negative 2 equals 2 over x. So basically we have 1 over 100, right? 10 to the negative 2 is really 1 over 10 squared equals 2 over x. You treat this like a proportion. You can cross multiply if you want, right? This looks like a proportion, does it not? So you can cross multiply. What's 2 times 100? That's 200. 1 times x is x. So x equals 200, and that would be our answer. Okay? That's it for today. We're just solving logarithms, so hopefully that was pretty painless for you. Again, I'll go back to what I referenced in the beginning. In lesson 9, we had exponential equations, which I asked you to solve with logarithms. That was in 9, and so in 10, we have log problems, and we're solving using exponential. If you keep that in mind, if you just think about opposite operations, inverse operations, and how to solve, I think you'll be on the right path. I look forward to seeing you in class and answering any questions you may have over the assignment.